Hey guys, welcome to our YouTube channel GurMantra Shiksha Ka Granth. I am Nidhi Dua and in this video lecture I am going to teach you the three most important topics named as Bohr's atomic model, second dual nature of matter and third Heisenberg's principle. So without any further delay, let's begin our first topic named as Bohr's atomic model. In 1913, Niels Bohr proposed a theory for the hydrogen atom based on quantum theory that energy is transferred only in certain well-defined quantities. He proposed some important postulates regarding hydrogen-like species or for hydrogen atom. The important postulates on which Bohr's model is based are: first postulate is about the structure of an atom, which states that atom has a nucleus where all the positive charge are collected. This positive charge is known as protons, and the size of nucleus is very small, and this small sized nucleus, this positive charge is present at the center of an atom. Second postulate tells about the negative charged electrons. Negatively charged electrons always revolves around the positive charge, that is nucleus, in the same way as the planets are revolving around the sun. Due to this reason, Bohr's atomic model is sometimes referred to as planetary model or planetary motion. As you can see in this slide, this positively charged nucleus is placed at the center of an atom where these red ball-like structures are your negative charge electrons, and these negative charge are revolving around this positive charge nucleus. The negative charge electrons are revolving in a path which is known as orbit, and these orbits have different energies. That's why these orbits are known as energy levels. The path of an electron is circular. The attraction force between nucleus and electron is equals to the centrifugal force of an electron. Here, this is very important to note that centrifugal force is a force which arises from the body's inertia and appears to act on a body moving in a circular path. And this centrifugal force is directed away from the center, means away from the nucleus around which the body is moving. Moving further to the next postulate, that is, electron can revolve only on those orbital whose angular momentum is the integral multiple of h by 2 pi, means angular momentum should be equals to nh upon 2 pi, where mvr is angular momentum, n is the number of orbitals, h is Planck's constant, and 2 pi is also a constant in which the value of pi is 3.14. Whereas m represents the mass, v represents the velocity, and r represents the radius. Angular momentum cannot have the fractional values. It should always be in a whole number. Next postulate is fourth postulate, which states as the time passes, electron remains in the stationary state and it will not lose any energy. Such a state where energy is not being loosed by the electron. That state is known as ground state. Fifth postulate is about the naming of these different orbitals. Each stationary orbit is associated with definite amount of energy, means each orbit has some amount of energy. Therefore, these orbits are also called energy levels. And these energy levels are numbered as 1, 2, 3, 4, 5 and so on, or K, L, M, N, O and so on. Moving forward to the next postulate, which explains the emission and absorption of energy. So, the number 1 point is emission or absorption of energy in the form of radiation can occur when electron jumps from one stationary state to another. Energy is absorbed when electron jumps from the inner orbit to outer orbit. Inner orbit is the nearest orbit to the nucleus, whereas outer orbit is the farthest orbit to the nucleus, and energy is emitted when electron moves from outer orbit to inner orbit. Next point is, when electron moves from inner to outer orbit, it absorbs some amount of energy, and the new state of electron is said to be excited state. Excited state is the state when an electron absorbs some amount of energy and moves to the further orbit. If electron is in its first excited state, that means electron is in its second orbital. So, by this point, you can get the clear relationship between excited state and orbit. Here are the two most important terms named as ionization energy and separation energy. So, the basic difference between ionization energy and separation energy is ionization energy is the required energy to liberate an electron from the ground state, while separation energy is the required energy to escape out an electron from its excited state. Now, this is very important to note that Bohr's model is only applicable up to monoelectronic species. Monoelectronic species means the elements which have a single electron in their electronic configuration, like hydrogen, He+, or Li+2 and so on. Now, in this slide, we are going to discuss about the application of Bohr's model. This application of Bohr model is very useful while solving the numerical problems. So, I would suggest here to please note down these formulas, these important formulas, and learn them, because these will help you to solve the numerical problems directly. So, the number one formula is about radius of various orbital. If we want to calculate the radius of orbit, we can simply calculate it by using this formula. The formula is R is equals to 0.529 into n square divided by z, where n represents the number of orbit, and z represents the atomic number of an electron, and this radius must be in the angstrom unit, or you can change this unit into meter, picometer and so on. That totally depends on the requirement of question. Second point is energy of an electron. We can calculate the energy of an electron by using this simple formula, that is E is equals to minus 13.6 Z square by N square, where Z represents the atomic number and N represents the number of orbital, which unit should be electrovolt per atom. In the next few points, you will get the clear relationship between energies. As you know, total energy is equals to kinetic energy and potential energy. So, these points will give you the relationship between kinetic energy, total energy and potential energy. As potential energy is equals to the minus of twice of kinetic energy, and kinetic energy is equals to the minus of total energy. Potential energy is equals to the twice of energy. In the next point, if we want to calculate the velocity of an electron, we can simply calculate it by using this formula, that is V is equals to 2.186 into 10 to the power 8 Z by N centimeter second inverse. I hope you guys are now cleared about the Bohr's model. Moving forward to the next topic, that is the dual nature of matter. Dual nature of matter was given by a scientist named Louis de-Broglie. Louis de-Broglie suggested that if the nature of light is both that of a particle and of a wave, then this dual behavior should be true for the matter also. The wave nature of light rays and X-rays is proven on the basis of their interference and diffraction techniques. This is very important to note that wave nature of light rays and X-rays are proven on the basis of interference and diffraction. De-Broglie gave the clear relationship between wavelength and the momentum. According to de-Broglie, wavelength lambda of an electron is inversely proportional to the momentum p. As you can see here, lambda is inversely proportional to 1 by p, where p represents the momentum, and you know that p is equals to mv. When you will remove this proportionality constant, you will apply a new constant, that is Planck's constant, and therefore the formula becomes lambda is equals to h by p, or lambda is equals to h by mv, as p is equals to mv. So therefore we get the solution as lambda is equals to h by mv. The above relation can be confined as follows by using Einstein's equation, Planck's quantum theory and wave theory of light. According to Einstein's equation, you know total energy is equals to the product of mass and the twice of speed of light. Planck's quantum theory is E is equals to h nu, and wave theory gives the relationship between nu and lambda, which is C is equals to nu into lambda. When you get all these equations and when you solve them, you will get the result as E is equals to hc by lambda. But according to Einstein's equation, you know that E is equals to mc square. So when you equals both the equation, number one equation E is equals to hc by lambda and number second equation E is equals to mc square, you will get mc is equals to h by lambda. And you know that the product of mass and velocity is momentum. So this is written as momentum is equals to h by lambda. And when you interchange this momentum and lambda, you will get the final result as lambda is equals to h by p. And this is proven that lambda is equals to h by p. It is clear from the above equation that the value of lambda decreases on increases either mass or velocity or both, because you know that the relationship between wavelength and momentum of an electron is inverse ratio. The wavelength of many fast moving objects like an aeroplane or a cricket ball is very low because of their higher masses. Now we have the next topic, Bohr's theory and de-Broglie concept. According to de-Broglie, the nature of an electron moving around the nucleus is like a wave. That means de-Broglie suggested that if the electron is moving around a nucleus, it must follow a wave nature that flows in a circular orbit around the positive charge, which is nucleus. If the radius of circular orbit is r, then the circumference of this circular orbit must be is equals to 2 pi r. And we know that according to Bohr's theory, mvr is equals to nh upon 2 pi, or when you interchange this formula, you will get 2 pi r is equals to nh upon mv. And you know that mv is momentum. So 2 pi r is equals to nh by p. And we get the clear relationship between Bohr's theory and de-Broglie concept as 2 pi r is equals to nh upon p. Next point explains that it is clear from the above description, from this above formula, that according to de-Broglie, there is a similarity between wave theory and Bohr's theory. I hope you are now cleared about this Bohr's theory and de-Broglie concept. Moving forward to our next topic, that is Heisenberg's uncertainty principle. Bohr's theory was considered as an electron as a material particle. So its position and momentum can be determined with accuracy. But when an electron is considered in the form of waves as suggested by de-Broglie, it was not possible to ascertain simultaneously the exact position and the velocity of an electron at a particular time. Which means at a particular time, at a single time, we cannot calculate its exact position and velocity simultaneously. Therefore, in 1927, Werner Heisenberg presented a principle known as Heisenberg's uncertainty principle, which states as it is impossible to measure simultaneously the exact position and exact momentum, the exact velocity of a body as small as an electron. Heisenberg gave the clear relationship between position and momentum, which is delta x dot delta p must be greater than or equals to h by 4 pi, where delta x is position and delta p is momentum. When we put the value of delta p as delta mv, we get the formula as delta x dot delta mv must be equals to or greater than h by 2 pi. For an electron of mass 9.10 into 10 to the power minus 28 gram, the product of uncertainty is quite large. this is very important to learn to know that the product of uncertainty of the mass of an electron is quite large, and the product and the solution is 0.57 erg second per gram approx. I would suggest here, please learn this value. The product of delta X or delta V is called as uncertainty product because this is the Heisenberg's principle that at a particular time you cannot calculate the exact position and velocity of an electron simultaneously. In the case of bigger particle, the value of uncertainty product is negligible. If the position is known quite accurately, that is, delta X is very small, delta V becomes large, and vice versa, because you know that delta X and delta V are in inverse ratio. They are in a multiple ratio. Now, this is very important to note that the importance of Heisenberg's principle, the importance of Heisenberg's uncertainty principle. This principle is based on the wave-particle duality of matter. It holds significant value in the quantum world, and this Heisenberg's principle gave the clear-cut relationship between delta X and delta P, which is your position and the velocity, and the relationship is delta X dot delta P must be equals to or greater than h by 4 pi. Now I hope you guys are very clear about the Heisenberg's principle, as in this unit we have covered 3 topics. Number 1 was Bohr's atomic model, number 2 was dual nature of matter, and number 3 is Heisenberg's principle. So this is all about this video lecture. Now there is an important announcement. If you are preparing for CSIR NET, you can follow Neha Taneja ma'am on Unacademy. There are plenty of courses, and on Unacademy platform you will get daily live classes. Also there are structural courses which will help you the best to prepare for upcoming CSIR NET exam. If you are interested, you can go with this detailed paid classes, and after using the referral code NEHA, you will get 10% discount on the total fee. Also, if you are new here, please do like, share and subscribe our YouTube channel named GurMantra Shiksha Ka Granth. You can also join our Telegram channel where you will get all the upcoming details and all the notes. You can also join our Facebook page named GurMantra Shiksha Ka Granth. For further queries, you can mail us on tanejanehaofficial@gmail.com, or you can contact us on 9351280000. Thank you. I hope you guys liked the video.